In this video, I'm going to show you how to build a model. Now, in this course, I don't expect you to build your own models, but I do want you to understand what a model is, so as you move forward in your education, if you do pursue data science in a more serious way, you'll already know what a model is and you'll have some idea how to start building one. So, to build a good model, you need to think small. And by thinking small, I mean thinking about the details. To build a good model, you need a good grasp of the details. There's an old saying, no grip, no clue. If you don't have a grip on the details, you won't have a clue how to solve a problem. We build models to help us solve problems. And specifically, we the models that we build generally involve numbers, and so the problems we're solving are quantitative problems. So to illustrate what it means to build a mathematical model, I've identified a little problem, and I've built a model that I'm going to show you that we can use to solve this problem. I will explain the problem and the model to you, and then working in your class groups, you will use the model to record some personal data in the table on the spreadsheet that you're looking at right now. Um, and then later in the model, we'll do some statistical analysis of the results. So the problem I decided on is this. How many days have passed since the day you were born, or since each of us was born? Maybe you've thought about that, maybe you haven't, but the question I'm asking is, how would you figure that out? And that's where building a model comes in. So let's start by figuring out what information we need to solve this problem. To do that, we need the following information. We need your date of birth, and we need the year and the month and the day corresponding to that particular date. Then we need to know today's date. So I'm going to start here, and I'm just going to put my birthday in here. And it's just like we would write a date on a piece of paper. Spreadsheets are pretty smart, and they know that that's a date. Okay, that looks like a date, January 7, 1953. And spreadsheets also have a function called today. So when we use spreadsheet functions, um, there's a lot of ways to get them. You can go up here and get them, and you can go down where it says date, and then you can go down to today. And you see it always has a parenthesis. And yes, I do want to stick in today's date. So I'm just going to hit return, and there it is, 4/19/2020. Now, of course, when I go to bed tonight and turn this off, and then I get up tomorrow, when I come in, it's going to say 4/30/2020 because it's today. It's a function in the spreadsheet. You can see here it's my birthday. It's not going to change. But when I come in tomorrow, it's still going to say equals today. So it's going to have tomorrow's date in there, and that's fine. So the problem is we can't really do any math with these dates, right? This is just sort of it might as well be a word because you can't do addition or subtraction or anything. And what we want to do is subtract this date in some way from this date. But we can't do it with what we have. We need to break this down into smaller parts. And that gets back to what I said about think small. So we actually let's do this. Let's try to figure out what year, what month, and what day each of these dates corresponds to. Well, again, it turns out there are functions in a spreadsheet that do that. Date, and I can go down and there's a function called year. And I can, well, again, I have to put something in here, I put a date in. Well, the date I have to put in is this date. So I just click on it. Now it says equals year B, column B, row 4. That's what I want. And I hit return, and now I've got 2020 here. Well, it turns out there's also a function month. So I know that function. I'm not even going to look it up. I'm just going to go equals MONTH, left parenthesis. I'm going to hit that date again, today's date, the today date, right parenthesis, and yes, April's the 4th month. And then finally, I'm going to say equals day. I'm going to hit the date again, right parenthesis, 29. So now I've I've broken this down into its components, and look what happened over here. Let me do this first, my birthday. So I'm going to do the same thing here. I'm going to say equals year, and I'm going to click on my birthday, date of birth, I should say. I'm going to say equals month. Once again, click on my date of birth and day. Click on my date of birth. So now I've broken it down. And look, these numbers change. Well, that's because I already put a formula in here. So what's the formula that I put in here? Well, let's think about this. First of all, what did I call this column? I said, how many days in the year until today? Meaning, how many days have passed in 2020 until today? So what do we know about months? Well, that's one of the reasons why this is an estimate. We're not going to actually get the exact number of days. We might get the exact number of days, but we're trying to do this in a very efficient way. So when you build a model, very often what you're looking for, almost always what you're looking for, is an estimate of the result you're really looking for. So we have this idea that there is a real answer out there. It's really difficult to find, but we are happy if we can get an answer that is pretty close to the actual answer. So that's what we're trying to do here. We're trying to get an answer that's pretty close to the number of days that I have been alive since the day I was born. So what I've done here is I've made a little formula where I've said, well, we know that it's the fourth month, but the fourth month is not over. So how many months have actually passed? Well, January's gone, February's gone, and March is gone. So that's 3. April's not quite gone. We've got 29 days in April. So we have 3 and some part of a fourth month. So what I want to do, the first thing I did here is I said, well, D4 minus 1. This is D4, the number of months that we're in, or the month that we're in. We're in the fourth month of the year. So and the other thing we know about months is some are 30 days, some are 31 days, February can be 28 or 29, depending upon whether or not it's a leap year. This was a leap year. But on average, months have 30 days. Okay? So I'm going to use 30, and I'm going to say we've got 3 full months that have gone by, and let's just say that was 30 days in each month. So the number of days is the number of the current month minus 1, because I don't want to count the current month. I just want to count the months that are already passed. So that's D4 in this case minus 1 times 30. So that's going to be, we're saying there's 3 months. They all had 30 days, even though we know they actually didn't, but we're going to pretend they had 30 days, plus however many days have passed in April. So that's what this formula does. It takes 4 minus 1, which is 3, times 30, which is 90, plus 29, which gives us 119. Now I'm going to do the same thing down here. I'm going to do D5 minus 1. Well, my birthday is in January, so that means no full months have passed when my birthday happens. Only 7 days have passed in the year. So my birthday happens on the 7th day of the year, approximately. Actually, it's exactly. And today's date is approximately 119 days into the year. It's actually a little more, but 119 is close enough. So what's the final thing we know? Well, we know that 3 years out of every 4 have 365 days. 1 year out of 4 has 366. It's a leap year. So that's a very easy thing to average. If 3 years have 365 days and 1 year has 366 days, then the total number of days, the average number of days over a 4-year period is 365 and a quarter. So what I've done here is I've put in 365 and a quarter, and that's the average days in a year. And finally, I want estimated days since birth. So that's a formula where I've got, okay, the one more, what I've got here is C7, which is the number of years. Down here, I took the total difference in years between today's date, 2020, and the date of my birth, 1953. and that's 67 years. So 67 years times 365 and a quarter, right? So C7, 67, times H5, 365 and a quarter, plus this number 112. 112 is how many, what's the difference, the days since my birthday? Well, if today is the 119th day of the year, my birthday was on the 7th day of the year, then 112 days have passed since my birthday. So if I take 67 full years times 365 and a quarter, and I add 112 to that, I get 24,583 and 3/4 days. Okay? Now I'm going to let you in on a secret. I've already told you that one of the great things about spreadsheets is that they can do a lot of math easily that would be a lot more work for us to do by hand. Well, every spreadsheet has a function in it that actually calculates the exact number of days. So that, in this case, in the Google spreadsheet, it's called date diff. So I put in here the date diff function. And the date diff function requires, give me the two dates you want. So I put in B5. I want to know the difference in days between my birthday and today's date. And I have to put a D up here because I want it in days. I don't want it, I could put it in months or years, but I want days. So for the function, the syntax for this function is date diff and then parenthesis, the first date, the second date, and the format you want it in, which in this case is days. So the true number of days since I was born is 24,584. Our model number of days is 24,583.75. So even though I estimated that every month had 30 days, and I estimated that every year had 365 and a quarter days, I didn't get the exact right answer, but I almost did. I got within 1/4 of a day. So I've put that here in this table. So what you all are going to do is when you're working in your groups in the class, you're going to open up this spreadsheet and each of you is going to put your birthday in. And all you have to do, today's date's the same for everybody. So for example, when I put my wife's birthday in 9/23/1952, all you have to do is put your birthday in there and everything else changes automatically. So in her case, the actual number of days is 24,690 days that she's been alive. The estimate is 24,693. So the difference in her case is that our model overestimated the number of days that she has been alive by 3. And I've put the rest of my children here, and you guys are all going to add your names and the same numbers here, and then we will talk about it. So this is a model, and in this case, it's a model where we can check the actual number, and that's a lot. That's essentially what we do when we build models. We build models to estimate data that we can't observe directly, and if possible, we try to compare it to things that we do to the actual numbers, if we are able to get those at some point. So in this case, we have a model that estimates how many days, and we actually have another way of computing the exact number of days. And we can see that this is a pretty good model because you can see all these numbers are really small. Now, when we talk about this the next time, we'll actually be talking about all these dates with all of your names and dates in here, and we'll be able to say something about these differences, and that gets into the realm of statistics. But for now, this is how a model works. This is how you use a spreadsheet to build it. It's a simple model. You have it available to you. You can check it out. Okay.